The 2016 Summer Olympic Games in Rio de Janeiro have just finished. The Olympic motto is Citius Altius Fortius, faster, higher, stronger. And those athletes who were trying to go higher had an unfair advantage this time around. They were able to jump nearly 0.25% higher in Rio than they were in London 4 years ago. Why? Well, because Rio is closer to the equator than London is, and effectively these athletes were experiencing less gravity. Why is that? Well, we're going to need some physics to figure it out. Think about a 24-hour day, one full rotation of the Earth. In that time, a point on the equator is going to travel about 40,000 kilometers through space, while a point on the poles will not travel any distance at all relative to the Earth. London, as you can see here, is located 51.5 degrees north of the equator, while Rio is located 22.9 degrees south. If we look at a cross-section of the Earth, we can see that London is about 4,000 kilometers away from the axis of rotation, while Rio is nearly 6,000 kilometers away. When you move in a circular path, even if your speed isn't changing, you are accelerating because your direction of movement is always changing. Now, this so-called centripetal acceleration is given by the formula v squared over r, where v is your tangential speed and r is the radius of your path. V is simply the distance over time, which for one full rotation is 2 pi r over t. So we can rewrite this formula as 4 pi squared r over t squared. Now, because r is in the numerator, a larger radius means a larger centripetal acceleration, so more acceleration in Rio than in London. Now let's shift our reference frame here to one that moves with the athletes around the world. Locally, we experience that centripetal acceleration as an apparent centrifugal force, one that accelerates us away from the center of rotation in the opposite direction to gravity. So for a body in free fall, we have the gravity force pulling down with F equals ma, and the opposing centrifugal force pulling up with F equals ma with a different acceleration. So the resulting net force here is the difference. Let's put some numbers in here. Let's assume that our athlete has 70 kilograms of mass, that the radius of the Earth is 6,371 kilometers, and that the acceleration due to gravity is the ISO standard of 9.80665 meters per second squared. We're going to need those significant figures. If we go through and work it out, we find that our athlete experiences
Mr. Black,
newtons of force in London and
Mr. Black,
newtons of force in Rio, a difference of
Mr. Black.
%. But that's not all. Because of this very same phenomenon, the Earth is actually slightly squashed, and so wider around the equator than it is around the poles. Now this causes some complex and competing effects on local gravity, but the end result is that the effect becomes even larger. The local gravity in Rio is about 0.24% weaker than it is in London. So in London in 2012, Lino Laviani won the men's pole vault with a jump of 5.97 meters. If he had done that exact same jump in Rio, he would have gained another 1.45 centimeters. And how high did Laviani jump in Rio? 5.98 meters, a difference of 1 centimeter. Coincidence? Yeah, probably just a coincidence.